When I'm presented with a more complicated problem like this one, it's a good idea to take a step back and actually form a plan of attack before I start doing some algebra. So I'm going to look at where do I want to end. And I want to end by finding the area of the shaded region. So I consider the picture. To find the area of the shaded region, I look at the area of this large rectangle, which is mostly shaded, but it's missing this part right here. It's like something's been subtracted or taken away. So if I write this out in words, I would think of this as the area of the large rectangle, but I have to take away the area of the small rectangle. That's my plan of attack. Find an expression for each of those and then subtract them. So first let's look at the area of the big. The big rectangle, when I do area, is length times width. So I need to take 3x plus 3 times x plus 5. And since they're binomials, I have to put them in parentheses. That reminds me right away that I'm multiplying using the FOIL method, or distributing twice. So I distribute the 3x to both of the pieces. That gives me 3x squared plus 15x. And then distribute the 3 to both pieces. That gives me positive 3x and then plus 15. So the area of the big is really 3x squared plus 18x plus 15. Now I turn my attention to the small. In order to find the area of the small, again, it's a rectangle, so it's length times width. So I begin to do that math, and I find that it's very similar to what I just did. I'm taking x minus 1 times x minus 2. So I'm FOILing it out again. Take the x to both pieces. That gives me x squared minus 2x. Take the negative 1 to both pieces. That gives me negative x and positive 2. So when I add everything vertically, the area of the small is x squared minus 3x plus 2. So far I have these two quantities here that I need to put into this expression that I wrote up here. Area of big minus area of small. So I'm going to put a line across, and I'm going to actually do this area calculation. So area of big, notice how I put it in parentheses. I'm going to continue to do that. So I have 3x squared plus 18x plus 15 minus, I'm going to put it in parentheses again, x squared minus 3x plus 2. What this turned into is a simple polynomial subtraction problem, where I have to distribute the negative 1 that's chilling out front here, and then I can actually combine like terms. So he's got to go to all three pieces. If I was trying to think, wait, what am I distributing here? It's just a positive 1, so that makes life easy. I don't have to worry about that. So I keep the 3x squared plus 18x plus 15 the same. This becomes minus x squared plus 3x minus 2. Now we're just down to a game of combining like terms. The x squareds with the x squareds, the x's with the x's, and lastly, the constants with the constants. So I can go right to my final answer. I end up with 2x squared plus 21x plus 13. That's the area of the shaded region. And again, I found that using the area of the big, the total region, minus the area of the smaller region. So there again is my final answer. It's a quadratic trinomial.